On a crisp winter night, if you look up into the velvet darkness, you'll spot a familiar pattern of stars. Orion the Hunter, standing tall and proud among the constellations. Orion is one of the most easily recognized shapes in the night sky, its stars forming a striking figure that has inspired stories and legends for thousands of years. This constellation is a celestial landmark, guiding stargazers and travelers alike through the long winter months. Its distinctive belt of 3 stars makes it easy to find, even for those new to astronomy. But if you trace Orion's outline, your eyes will be drawn to his right shoulder, where a brilliant reddish star flickers in the cold night air. This is Betelgeuse, a star that stands out not just for its color, but for its restless, ever-changing brightness. Betelgeuse is a red supergiant, one of the largest and most luminous stars visible to the naked eye. It's a true cosmic heavyweight, swelling to hundreds of times the size of our Sun, and glowing with a deep, fiery hue that hints at its turbulent nature. Unlike our Sun, which will quietly fade away in billions of years, Betelgeuse is nearing the end of its life in dramatic fashion. When its time comes, it won't simply dim and disappear. It will explode in a spectacular supernova, briefly outshining entire galaxies. Because of this, astronomers around the world keep a close watch on Betelgeuse, monitoring every flicker and change in brightness. They're waiting for the moment when this giant finally erupts, an event that could happen tomorrow, or thousands of years from now. Betelgeuse is also a runaway star, hurtling through space at incredible speeds. As it plows through the interstellar medium, it creates a vast bow-shock, an arc of gas and dust stretching 4 light-years wide, a testament to its restless journey. Its deep red glow is a striking contrast to the icy blue-white light of Rigel, Orion's other bright star, found at the Hunter's foot. These 2 stars, side by side in the same constellation, represent 2 very different stages in the life of a star. Observing Betelgeuse and Rigel together is like reading 2 chapters of the universe's story at once. One star just beginning its journey, burning hot and young, while the other nears its final explosive act. Betelgeuse reminds us that even the mightiest stars are not eternal. Their lives are filled with drama and change, and some, like Betelgeuse, will end with a bang so bright it will light up our night sky, a cosmic finale written in the stars. To truly grasp Betelgeuse's astonishing nature, we need to put its size into perspective. Imagine if Betelgeuse were to suddenly replace our Sun at the center of the solar system. Its vast, fiery surface would stretch far beyond the orbits of Mercury, Venus, Earth, and Mars, completely engulfing them. In fact, its outer edge might even reach as far as Jupiter, swallowing up everything we know as the inner solar system. The scale is almost impossible to comprehend. A single star so large that it could contain the orbits of several planets within its glowing, turbulent atmosphere. Our entire inner solar system, planets, moons, and all, would fit comfortably inside this one colossal star. Betelgeuse's sheer size dwarfs everything in our cosmic neighborhood, making even our Sun look like a tiny spark by comparison. Betelgeuse's story began just 10 million years ago, a blink of an eye in cosmic terms. But with more than 20 times the mass of our Sun, it has lived a life of extremes. Massive stars like Betelgeuse burn through their fuel at a furious pace, shining brilliantly but living fast and dying young. In its short lifetime, Betelgeuse has already gone through dramatic changes, growing ever larger and more unstable as it ages. As Betelgeuse burns through its nuclear fuel, its outer layers have ballooned outward, expanding to hundreds of times the Sun's diameter. These layers have cooled as they stretched, giving Betelgeuse its distinctive red glow. The star's surface is not solid, but a roiling, ever-changing sea of hot gas, constantly shifting and bubbling. Over time, Betelgeuse has lost a significant portion of its mass, blown away by fierce stellar winds that stream out into space. These powerful outflows create a vast cloud of gas and dust around the star, evidence of its ongoing struggle to hold itself together. Yet, deep inside, its core remains incredibly dense and heavy, destined to collapse and trigger a spectacular supernova explosion. The star's outer atmosphere is now unstable and pulsating, swelling and shrinking in a slow, chaotic rhythm. These pulsations are a sign of the turmoil within, as Betelgeuse's internal structure becomes more and more unstable with each passing year. Betelgeuse is literally tearing itself apart from the inside out. Its core is fusing heavier and heavier elements, while the outer layers are buffeted by shockwaves and turbulence, making the star's surface appear distorted and restless. Despite its incredible size and power, Betelgeuse is still just a neighbor in our galactic backyard, about 550 to 640 light-years away. That's close enough that when it finally explodes, the event will be visible from Earth, but far enough that we'll be perfectly safe from any harmful effects. When Betelgeuse goes supernova, it will be the closest such explosion witnessed in modern history. The night sky will be transformed, as the dying star briefly outshines every other point of light except the moon. We are truly fortunate to have a front-row seat to this cosmic finale, a rare opportunity to witness the dramatic end of a supergiant star, and to marvel at the immense forces that shape our universe. Betelgeuse isn't just bright, it's unpredictable. Ancient astronomers saw it change from yellow to orange to the deep red we see today, a sign of its ongoing transformation. It's a semi-regular variable star, pulsing in brightness every 400 days, with other longer cycles adding to its complexity. Astronomers track these changes, watching the star's heartbeat as it nears its end. Its surface is a boiling chaos of giant convective cells, bubbles of plasma as big as Earth's orbit. These create bright and dark patches, making Betelgeuse's light flicker and shift. We're witnessing the turbulent death throes of a giant. Every change in brightness is a clue to the physics deep inside. Betelgeuse is a living laboratory for stellar evolution. Its recent wild behavior hints that its final act may be closer than we think. In late 2019, Betelgeuse stunned the world by dimming dramatically, losing 2/3 of its brightness. Stargazers everywhere wondered, was this the prelude to a supernova? Telescopes worldwide turned to Orion, waiting for history to unfold. But the real cause was a massive surface eruption. Betelgeuse ejected a huge blob of plasma, which cooled and formed a dust cloud that blocked its light. This great dimming wasn't the end, but it revealed just how violent and unstable Betelgeuse's surface can be. The event was a cosmic detective story, solved by data from Hubble and other observatories. It showed us that red supergiants can shed mass in spectacular fashion. While not the supernova we hoped for, the dimming was a historic event in its own right. Betelgeuse remains a star full of surprises. Just as astronomers thought they understood Betelgeuse, it brightened dramatically in spring 2023, becoming the 7th brightest star in the sky. This surge puzzled scientists. It didn't fit the usual pulsation cycle. Some think the great dimming disrupted the star's surface, and as it recovered, energy was released in a powerful burst. It's like shaking a soda bottle. After the initial fizz, there's a sudden surge. These wild swings show how little we know about a star's final moments. The dimming and brightening are clues to the chaos inside. Betelgeuse is in a volatile state, its behavior growing more erratic. While neither event was the supernova, they're tremors before the quake. The star's next move is anyone's guess. The big question on every astronomer's mind is this: when will Betelgeuse finally explode in a spectacular supernova? This red supergiant, one of the brightest and most famous stars in our night sky, has captured human curiosity for centuries. Its fate is sealed, but the timing remains a cosmic mystery. The truth is, no one knows for sure. Despite decades of observation and advanced technology, Betelgeuse keeps its secrets well hidden. Scientists can only make educated guesses, and even the best models leave us with a wide range of possibilities. Predicting the exact moment of a supernova is nearly impossible. The final collapse that triggers the explosion happens deep within the star's core, far beyond the reach of our telescopes. All the warning signs are buried under layers of gas and plasma, invisible to us until it's too late. Estimates for Betelgeuse's explosion range wildly, from as soon as tomorrow to as far as 100,000 years in the future. In cosmic terms, that's the blink of an eye, but for us, it's an agonizing wait. Right now, Betelgeuse is likely fusing carbon in its core, a process that will soon give way to the burning of heavier elements like neon, oxygen, and finally silicon. Each stage happens faster than the last, as the star races toward its inevitable end. The final silicon burning phase is the shortest of all, lasting just about a day before the core collapses under its own gravity. When that moment comes, the star's outer layers will be blasted into space in a brilliant supernova. But there's another twist. Betelgeuse is over 500 light-years away. That means the light we see tonight actually left the star centuries ago. It's possible Betelgeuse has already exploded and the news just hasn't reached us yet. Every night, as we gaze up at that familiar red dot, we might be looking at a ghost, a star that's already gone, its final act still traveling through the vastness of space toward Earth. The recent episodes of Betelgeuse dimming and brightening have sparked excitement and speculation. While these fluctuations suggest the star is unstable, they don't necessarily mean the end is imminent. Red supergiants are known for their dramatic changes. For now, astronomers around the world keep their telescopes trained on Betelgeuse, waiting for the first sign of the universe's greatest light show. It could happen in our lifetime, or it could be a gift for future generations. Betelgeuse is a ticking cosmic time bomb with an unknown timer, reminding us how much of the universe's drama unfolds on a timescale far beyond our own. When Betelgeuse finally explodes, the first sign won't be light but a flood of neutrinos, ghostly particles racing ahead of the blast. Earth's neutrino detectors will pick up this burst, giving astronomers a few hours warning before the light show begins. Then, Betelgeuse will brighten by thousands of times in minutes, outshining everything but the moon. For months, it will be visible even in daylight, a new star in the sky. At night, it will cast shadows and transform our view of Orion. After peaking, it will slowly fade over a year or two, leaving behind a glowing nebula. Through telescopes, we'll watch the expanding remnant for centuries. The supernova will be a once-in-a-lifetime spectacle. It will change the night sky and our understanding of stellar death. Humanity will witness a cosmic finale in real time. Is Betelgeuse's supernova dangerous? Not at all. It's over 500 light-years away, far outside the danger zone. The explosion's radiation will be harmless by the time it reaches us. The only risk is to your eyes if you look at it through a telescope or binoculars at peak brightness, so follow safety advice. The supernova will be a global event, uniting billions in awe. It will inspire new generations of scientists and stargazers. For researchers, it's a scientific goldmine, offering data on stellar death, neutrinos, and the creation of heavy elements. The neutrino burst will revolutionize our understanding of dying stars. The light will reveal the structure of Betelgeuse and its surroundings. It will be a defining moment for 21st century astronomy. Betelgeuse's explosion will be more than a spectacle. It will transform astronomy. For the first time, we'll have a complete before and after record of a supernova. This will let us test and refine our theories of stellar explosions like never before. We'll finally see how a core collapse shockwave really works thanks to the timing of neutrinos and light. The supernova's light will illuminate shells of gas and dust, mapping Betelgeuse's history in 3 dimensions. We'll learn how massive stars enrich the galaxy with the elements needed for life. This is a rare chance to witness the universe's most dramatic process up close. Whenever it happens, Betelgeuse's final act will be a gift of wonder and knowledge to humanity.